Did you know that one modern wind turbine can power 16,000 homes? Just 40 years ago, technology like this didn't even exist. Since 2009, wind energy generation in the UK has increased by over 715%. Today, I want to explain how wind turbines work, how efficient they really are, and what's changed since the first UK turbine was installed back in 1987, all with a landowner's perspective in mind. At a basic level, wind turbines convert the energy in moving air into electricity. The wind turns the blades, the rotor spins, and a generator produces electricity that is exported to the grid. Location is critical. Sites with stronger and more consistent winds generate significantly more electricity than lower wind locations. This is why offshore wind turbines are generally larger than onshore turbines. Offshore locations experience stronger and more reliable winds, allowing turbines to operate more efficiently for longer periods. No turbine is ever 100% efficient. In real-world conditions, turbines typically range between 20 and 50% efficiency, depending on wind strength and time of the year. During strong wind periods, efficiency can approach 50%. When winds are lighter, it drops closer to 20%. What is often overlooked is availability. On average, wind turbines generate electricity for around 80% of the year, making wind one of the most reliable renewable technologies in the UK. To understand performance properly, it helps to introduce one key term: capacity factor. Capacity factor is a ratio of a wind turbine's actual electricity output compared to its maximum possible output if it operated at full capacity all of the time. In the UK, wind farms typically achieve around a 25 to 35% capacity factor. Offshore wind farms generally perform better, often reaching 40 to 50%. Capacity factor matters because it directly affects revenue. Where landowners' income is linked to turnover, higher capacity factors usually mean higher returns. Wind energy is clean, renewable, and produces no air pollution. The UK climate and geography make it particularly well suited to wind generation. Wind power is also central to the UK's net zero targets. While emissions have fallen since 1990, further reductions are still required. As at 2023, the UK had around 11,000 wind turbines installed onshore and offshore, with a combined installed capacity of 28 gigawatts. The UK's shallow continental shelf also makes offshore wind farms especially viable at scale. Onshore wind refers to wind projects built on land. These can range from a single turbine to large multi-turbine wind farms. Landowners typically lease their land to enable the installation of turbine foundations, access tracks, and substations. Onshore wind has historically faced planning resistance in England, but planning rules are now beginning to reopen new development opportunities. Offshore wind farms are located at sea and are usually developed at a much larger scale. Although landowners do not lease the seabed, coastal estates may host onshore infrastructure, such as cable landfalls and substations, which can require easements or lease agreements. The UK's first turbine was installed in July 1987 in Orkney, with a capacity of 3.7 megawatts. Now, since then, turbines have increased dramatically in size and output. In 2017, an onshore turbine with a capacity of 4.8 megawatts was installed, featuring a rotor diameter of 158 meters and a tip height reaching 240 meters. Now, in 2018, GE Renewable Energy revealed a turbine standing at 260 meters tall, designed to supply enough electricity for 16,000 homes. This increase in scale is one of the main reasons wind turbine efficiency has improved over time. And one of the biggest drivers of efficiency is hub heights. Since 1998, average turbine heights have increased by around 66%. Taller turbines access stronger winds and experience less turbulence from ground level obstacles. Rotor diameter have also grown significantly. Over the last 30 years, the average rotor diameter worldwide has increased from around 20 meters to around 129 meters, allowing turbines to capture more energy. Now, materials have also improved alongside scale. Modern turbines use advanced glass and carbon fiber composites that are lighter, stronger, and more durable. Between 84 and 90% of turbines use recyclable materials. Reliability has also improved through predictive maintenance. Modern turbines use sensors to detect potential faults before they even occur, reducing downtime and improving performance. Now, repowering is the process of replacing older turbines with newer, taller, and more efficient models at the same sites. In the UK, repowering is becoming increasingly common as wind farms built in the 90s and early 2000s reach the end of their original life. Repowering often reduces turbine numbers while increasing the total outputs that can be achieved by a fewer number of turbines and require new lease renegotiations. Grid connection is the technical and contractual right to connect a project to the electricity network. Without a confirmed grid connection, no renewable project can proceed. For landowners, this makes grid access one of the most important issues to understand before entering even an option agreement or a lease. Throughout this video, I've used several industry terms. If you're new to renewables, this terminology can be confusing. This is why we've created a renewable energy definitions guide. It breaks down each term in plain English, shows how it applies on real projects, and explains why it affects feasibility and income. Please check it out. There's a link in the description below. Thanks for watching, and I'll see you in the next video.